Hello once again, this is Mr. V. Hill. Today we're going to be solving equations with variables on both sides of the equal sign. And we're just going to go through a couple of quick examples here. First one we have, you'll notice we have 5x on this side and an x inside the parentheses on this side. So we can't undo what's being done to x yet. We have to first simplify some and then combine the like terms. So first off, what we're going to do is start simplifying here. Of course, this x is trapped inside the parentheses, so we need to distribute this multiplying by 3. Oops, I want this to be a plus 8. And so we have 5x minus 7 is equal to 3x plus 3 times 8 is 24 minus 25. And then, of course, we know that 24 minus 25 is going to be a negative 1. So what we really have here is 5x minus 7 is equal to 3x minus 1. And, of course, if you don't want to deal with the subtractions, you can, of course, switch those to adding the negative of the next term. But I'm just leaving them in there for right now, just for a goof. So now, we can't really combine these like terms here with x in them because they're separated by the equal sign. But what we can do is we can apply a property of equality and subtract the same thing from both sides, or add the same thing to both sides. So basically the idea is to get rid of the variable term on one side. And it doesn't matter which one you want to do. Either way will work just fine. So I'm going to get rid of these 5x's on the left-hand side. So we'll subtract 5x from the left-hand side, and we'll also subtract 5x from the right-hand side so that things will stay equal. And so what happens there is this 5x minus 5x, those cancel each other out. We're left with just negative 7 on the left-hand side, and that's going to be equal to 3x minus a 5x is negative 2x. Then we also have a minus 1. And now we can just undo what's being done to this unknown x now. Back in the situation of just a regular old two-step equation. If we want to, we can make a little table. First thing being done to x is multiplying by negative 2. We undo that by dividing by negative 2. Next thing, we subtract 1. We undo that by adding 1. So we apply those inverse operations in reverse order to both sides of the equal sign. And so we add 1 over here, we add 1 over here. Those two things will cancel out. So negative 7 plus 1 is negative 6. That's now equal to negative 2x. Now, we've done this adding 1. Now let's go up here and divide both sides by negative 2. Because this factor of negative 2 on top and this factor of negative 2 on bottom will cancel each other out. And so we're left with just x on the right-hand side. And negative 6 divided by negative 2 is, of course, just 3. So that's what x is. We could put it in solution set notation if we wanted to. I'm not a big stickler about that. So now let's just check our answer by plugging it back into the original equation. And we ask ourselves, is it actually true that 5 times 3 minus 7 is equal to 3 times 3 plus 8, just putting a 3 for that x as well, minus 25. Is that a true statement? Well, let's see here. This is 5 times 3 is 15, minus 7, that's 8. Let's see here. 3 plus 8 is 11. So is that a true statement? Well, 3 times 11 is 33. Minus 25, is that equal to 8? Yes, it sure is. We did it correctly. Fantastic. So the basic idea here is when you have variables on both sides of the equation, we just want to get rid of them on one side. And then we'll be back to a situation that we know how to deal with. Let's do a slightly more difficult example. Now this is actually a proportion, meaning one ratio equaling another ratio. And you might have heard about cross multiplication, all that nonsense, but let's just do this like we know how to do. First off, what we could do is simplify both sides of the equation. And we're going to do this a couple different ways, actually. So first off, the problem here is that actually we have parentheses around both the numerator and the denominator because the vinculum is a grouping symbol. And so really we need to distribute this dividing by 6 and this dividing by 4. Or if you want to get back into how we normally look at the distributive property, dividing by 6 is the same thing as multiplying by 1/6. So we could rewrite the equation as 1/6 times the quantity x plus 3 is equal to 1/4 times the quantity 2x minus 8. Now we distribute this 1/6 in and also this 1/4 in. And we have 1/6 x plus 1/6 times 3 is of course 1/2. 1/4 times 2x is actually going to be 1/2 x, because 1/4 times 2 is 1/2, minus 1/4 times 8 is 2. Now we're back in the same old situation where we have our unknown on both sides, so we'll just get rid of them on one side. We subtract 1/6 x from this side, subtract 1/6 x from this side. These things are going to go away. And we have 1/2 on the left is equal to, well, let's combine these like terms. 1/2 x is the same thing as 3/6 x. Subtract off 1/6 x, and we're left 2/6 x, or 1/3 x, minus 2. And now we just undo what's being done to x here. We undo things in reverse order, so first we got to get rid of the subtracting 2. We do that by adding 2 to both sides. So these things will cancel out. 1/2 plus 2 is of course 5/2, and that's now equaling 1/3 x. We undo multiplying by 1/3 by multiplying by 3. Do that to both sides. These things are going to cancel out because 3 times 1/3 is 1. And 3 times 5/2 is 15/2. And that equals x. And of course you would want to take this value 15/2 and plug it back in up here for x and make sure you get a true statement out to check your answer. Now, a lot of people are going to get upset with these fractions. Oh no, they're fractions, they're hard to deal with. Well, I would encourage you just to get comfortable with fractions. They're just numbers like anything else. But what we could also do is do a little trick here. So we've got x plus 3 over 6 is equal to 2x minus 8 over 4. And the trick that I'm going to do is I'm going to multiply both sides of the equation by 12. The reason why I'm choosing 12 here is because the least common multiple of 6 and 4 is 12. We could have multiplied by 24 too, the product of these two things, but that doesn't really matter either way. And this is what's called clearing the denominators. It's another way of looking at cross multiplication, but I hate appealing to a magical butterfly in order to solve equations. Whereas we know that if two things are equal, we multiply them by the same things, they're still equal. That makes a lot more sense than appealing to a magical butterfly. But anyways, this 12 on top and the 6 on bottom, well, that is of course 12 divided by 6 is just 2. So really what we have is here 2 times the quantity x plus 3 is equal to, and 4 goes into 12 3 times. So 12 divided by 4 is 3. We have 2x minus 8 times 3. Now a little bit more comfortable with this because, hey, no fractions, wonderful. So now we just simplify both sides by applying the distributive property. 2x plus 2 times 3 is 6 is equal to 2x times 3 is 6x minus 8 times 3 is 24. And now we know how to deal with this. We just get rid of the x's on one side by subtracting them off. 2x minus 2x goes away. And now we're left with 6 on the left-hand side. 6x minus 2x is 4x. Still have our minus 24. And now we're set up to just undo what's being done to the variable x. So first we undo the subtracting 24 by adding 24 to both sides, so that those two things will cancel each other out. So we're left with 4x on the right. 6 plus 24 is, of course, 30 on the left. Now we undo the multiplying by 4 by dividing both sides by 4. 4 on top cancels with the 4 on bottom there. On the right-hand side, we have just x now. And of course, 30 over 4 simplifies down to 15 halves again. And of course, we'd want to check. And we could put this in set notation, but not a big deal. And a lot of people like this a lot better just because you don't have to deal with fractions. But I would encourage you to just be comfortable with fractions as well. And so, once again, I leave you with some practice problems. Very similar to the examples that we just did. Work through these, check your answers, make sure you understand what's going on. If you don't, watch the video again. Oh, and also make sure you're putting some comments in the down below on my YouTube channel. If you have questions, post them in there. If a lot of people have the same questions, I'll be sure to answer them in class tomorrow, next time we come together. All right? Thanks so much for watching.